Good afternoon, students. Today we are going to study free fall. If we release an object from a height, it gets pulled towards the earth because of the gravitational force. So, an object falling solely under the influence of gravitational force is said to be in free fall. Suppose an object is released, then what will happen? It will fall freely because of the gravitational force. Let us find out the kinetic and potential energies of an object of mass m falling freely from a height h when the object is at different heights. Energies at point A. We'll find out. First we'll find out the kinetic energy. The formula of the kinetic energy is half mv square. Now at point A, object is falling freely, so initial velocity is 0. So here the velocity is 0. So obviously kinetic energy is equals to half m0 equals to 0. Now we'll find out the potential energy. The formula of the potential energy is mgh. So here the mass of an object is m, acceleration due to gravity is g, and the height from A to C is h. So mgh is the potential energy. mgh is a potential energy. So the total energy is kinetic energy plus potential energy, which is equals to kinetic energy is 0 and potential energy is mgh. Therefore it is equals to mgh. So this is the energies at point A. Now let's find out the energy at point B. Here when the objects fall from point A, it reaches at point B. At this position, suppose the velocity is vb. So first we will find out the kinetic energy. Kinetic energy is half mv square. Now velocity is vb. So we will write vb square. Now we will find out the expression for vb. As you know from the equation of motion, v square is equals to u square plus 2as. Here the initial velocity is 0 as object is falling freely. Initial velocity is 0. A is equals to acceleration due to gravity and s. This s is equals to the distance travelled by an object from A to B, and suppose this distance is x, then s is equals to x. Okay, so initial velocity is 0, A is g, s is equals to x, and capital V is vb. So vb square is equals to, this is 0 plus 2gx. We'll solve it. This will become 2gx. So vb square is equals to 2gx. We'll put this value here. So kinetic energy will become half m into 2gx. This 2 and 2 get cancelled and this will become mgx. So kinetic energy is mgx. Now we will find out the potential energy. Potential energy at point B. Here the formula of potential energy is mgh. So mg, now what is h? Observe it carefully. The total distance is h, total height is h. From A to B it is x. So the height of the object from the ground to B is equals to h minus x. So this is equals to mgh minus mgx. This is a potential energy. Now we will add these two energies, kinetic energy and potential energy. So the total energy is equals to kinetic energy plus potential energy, which is equals to mgx plus mgh minus mgx. So this minus mgx and plus mgh get cancelled and this will become mgh. So the total energy at point B is mgh. Now let's find out the energy at point C. At point C, where the object reaches the ground, final velocity v is vc, a is equals to g, and the distance travelled from A to S is h. So S is equals to displacement is h. Now we will use the equation of motion, that is v square is equals to u square plus 2as. Here initial velocity is 0 as object starts from rest. So u is equals to 0 plus 2g, s is h, and v is, this is vc square. So vc square is equals to 2gh. Now we will find out the kinetic energy. Kinetic energy is half mv square. So here half mvc square, and vc is equals to 2gh. So half m into 2gh from here. So 2 and 2 get cancelled. This is equals to mgh. Kinetic energy is equals to mgh at. Now let's find out the potential energy. As we know, the formula of potential energy is mgh. Here at the point C, h is equals to 0. Therefore potential energy is 0. So the total energy is kinetic energy plus potential energy, which is equals to, kinetic energy is mgh and potential energy is 0. Therefore it is equals to mgh. So from these calculations we come to know total energy, the sum of potential and kinetic energy at point A, as we have calculated, it is equals to mgh. At point B is also mgh, and at point C it is also mgh. So the energy at point A, B and C, when an object is falling freely, you can see it is equal, and this is also we get the conclusion that energies can convert from one form to another, but the total energy remains same, or energy is conserved. That is a law of conservation of energy.